On September 1st, 2017, the largest asteroid that has ever approached our planet in the history of astronomical observations flew near Earth. It's named Florence and is 2.9 miles in size, quite enough to destroy human civilization. It's often impossible to predict threats coming from space. In 2013, a meteorite, which was way smaller, just 60 feet, exploded in the sky over Chelyabinsk in Russia, and its largest fragment fell into Lake Chibarkul. The shockwave not only shattered the windows in hundreds of houses and destroyed the fence around the zinc plant, it also orbited the planet twice.
Of course, the Chelyabinsk meteor caused some damage, but thankfully there were no victims. The scenario could have been much worse if it had entered the atmosphere at a steeper trajectory. Its kinetic energy is 30 times more powerful than the nuclear bomb that hit Hiroshima. The residents of Chelyabinsk were saved by the fact that the explosion happened at an altitude of more than 20 kilometers. Even so, more than 1,500 people were injured. Neither Russian nor foreign astronomers could predict the meteorite's fall. So, is humanity totally defenseless against a meteorite threat? Or was the Chelyabinsk explosion a rare exception? Are there real technologies that will destroy a dangerous asteroid? Or were they made up by Hollywood screenwriters? Let's find out.
Incidents similar to the Chelyabinsk one occur quite frequently. In 1908, the Tunguska meteorite exploded in the sky above a dense forest. It was twice as big as the Chelyabinsk meteorite, and the shockwave knocked down trees within a 25-mile radius. This explosion can be compared to the most powerful hydrogen bomb in history, but the Tunguska meteorite is effectively the size of a pea compared to the many giants that threaten our planet from outer space.
Before asteroids become meteorites, the scientific term given to cosmic objects falling to Earth, this is mankind's best opportunity to escape disaster. If you believe sci-fi films, the military own a variety of technologies that can protect the planet from flying space rocks. But in order to fight a threat, it must be discovered in time.
According to contemporary estimates, virtually all of the 30,000 meteorites found on Earth's surface appeared in the asteroid belt at some point in history. This is a region of the solar system located between the orbits of Mars and Jupiter.
Most of these giant rocks are formed in the asteroid belt. When falling to Earth, they are not just a bright light in the sky. They have the potential to be catastrophic, to varying degrees. Many are influenced at times by Jupiter. First of all, they radically change their trajectory and begin to fly towards Earth. Such objects are called asteroids, approaching Earth.
Scientists have discovered more than 100,000 asteroids, so why couldn't a telescope detect a cosmic object flying towards Earth? Asteroids are monitored with two types of telescopes. Firstly, with a survey telescope that gives a wider view. The telescope takes pictures at specified intervals. When the images are overlaid, we get an animation. If an asteroid enters the field of view, it will be the only moving object against the fixed stars in the background. After that, more powerful telescopes with a smaller viewing angle start their work. They are adjusted to specific coordinates and conduct a more detailed study of the asteroid.
This is the Pallas asteroid. We had been monitoring the sky when it was caught in the field. The program identified it, its reflectance was estimated at 7.2, and it was attributed the serial number 2. Its size is about 300 miles across. It's not dangerous, and it is a good example of asteroids in the main belt.
Brightness or reflectance, is the main property of cosmic bodies. Thanks to it, they can be seen through a telescope from Earth. Moreover, the larger the object, the brighter it glows. Therefore, dangerous large asteroids, larger than 1 mile in diameter, can be found dozens of years prior to any potential collision with our planet. But even with our current technical capabilities, it's still hard to detect objects smaller than 300 feet in size, such as the Chelyabinsk meteorite, even ones in close proximity to Earth.
Now we are working on equipment that can allow us to monitor the whole celestial sphere 3 or 4 times over the course of one night and discover 70 or 100-foot objects 1 or 2 days before they reach Earth.
Given that detection systems like this exist, then why did astronomers fail to warn the residents of Chelyabinsk about the deadly threat in time?
The Chelyabinsk meteorite wasn't detected by this system because this system doesn't exist today. There are several observatories which have telescopes of different sizes that track objects at different distances from Earth, but they don't cover the whole sky.
In Russia, Europe, and the USA, there are a large number of observatories which have modern telescopes. They're united in a single network. Scientists constantly exchange data. They are often hampered by bad weather conditions and dense clouds. But even if the sky is absolutely clear, there's always a blind zone when observing asteroids from Earth.
The Chelyabinsk meteor approached Earth from the Sun. That region of outer space is impossible to monitor from Earth because we cannot look at the Sun during the daytime. For that reason, the Chelyabinsk meteor was not detected in advance. Moreover, it was comparatively small in size, about 50 or 60 feet.
Finally, the problem of detecting small asteroids from Earth can be solved only with the help of space telescopes.
Theoretically, the system for detecting asteroids from space looks could involve one or several telescopes placed on a spacecraft platform. At the moment, the NEO-Y system for detecting hazardous near-Earth asteroids in infrared range already exists. In our institution and all over Russia, we are working on a daytime observation system of asteroids, SODA, to detect asteroids flying from the Sun.
In the foreseeable future, scientists plan to launch a spacecraft towards the Sun to the so-called Lagrangian point, L1, which is almost 1 million miles away. The spacecraft will remain stationary at the point relative to the Sun.
Now, there are quite a few spacecraft. The most famous of them is known as SOHO. It takes pictures of the Sun and we can observe solar winds. A spacecraft launched towards this point would be able to look sideways and detect asteroids flying past it from the Sun towards Earth, which cannot be seen from the ground. It would be able to register them 16 hours before any collision with Earth.
If we know about small asteroids coming our way at least 16 hours in advance, then we have a chance to evacuate and prevent disaster. The unwelcome visitor will only cause an economic damage.
A meteorite like the one in Chelyabinsk can destroy a small city, and an asteroid measuring 300 to 600 feet in diameter will erase an entire megapolis, comparable to a major city like Moscow or New York. The diameter of the crater would be about 2.5 miles wide. Imagine residential districts turning into a huge trench with a shockwave that would destroy thousands of buildings and kill millions of people. An asteroid with a diameter of 0.5 mile would leave billions dead. 3 miles, and we would be facing global climate change to the extent that most life on Earth would be near impossible.
Scientists believe the fall of a large celestial body was the end of dinosaurs. Fortunately, in the foreseeable future, the probability of a collision with such a celestial body measuring more than 1 mile in size is very low.
At the moment, we know about 99% of all 1 mile diameter objects existing near Earth. So, anything bigger doesn't pose a threat. All the objects that we have just discovered are well known. Their orbits are accurately calculated, and we do not expect any threats for many hundreds of years. As for smaller objects, we know only about 7% of all objects, with measuring around 500 feet. And of course, they pose a threat.
The threat is such that a falling object would force us to evacuate entire regions. Or will scientists find a way to deal with space rocks?
If a dangerous asteroid is detected in advance, several years before, like 5 years, 10 years prior to a potential collision with Earth, it is always possible to change its orbit. What ways are there to do it? That's a different question. But nowadays, systems are being developed to remove an asteroid from a collisional orbit. For example, by using a laser beam from a spacecraft, or actually on the asteroid.
The D-Star project in America has existed for 10 years. It plans the launch of a powerful laser gun with solar batteries into space. The batteries are just over a half-mile long, so we'll have to assemble the gun in orbit, not on the ground.
With the help of such a device, it is planned to influence asteroids with the help of a laser beam in the future. The orbit of a dangerous asteroid is supposed to be changed by evaporating the substance from the surface of the asteroid with a temperature of up to 3,000 degrees Kelvin or 5,000 degrees Fahrenheit.
A huge space laser gun seems like something out of a sci-fi movie. But back in 2005, NASA, for the first time in history, attacked the comet Tempel 1, dropping a metal probe onto it. It rammed the surface, causing the release of matter weighing about 10,000 tons. All of this was done to analyze the composition of the comet. But at the same time, it paved the way for an experiment called DART. It will help NASA experts understand how asteroids would behave if attacked by a metal shell about the size of a domestic refrigerator.
The impact will happen at a speed of 15,000 kilometers per hour. That's 10 times faster than a bullet. The target will be a double asteroid, Didymos, which is at a safe distance from Earth. It consists of two asteroids with a diameter size of 2,500 and 500 feet. The small one revolves around the bigger one. In 2022, DART will hit the smaller object, slightly changing its orbit.
NASA experts say that the small asteroid will eventually change the trajectory of the larger one. Nobody knows whether this courageous experiment will succeed or not. However, many Russian scientists believe that the impact probes are useless against the large, single asteroids, and they propose fighting fire with fire.
Another method, which also seems technically feasible, is to collide smaller asteroids with bigger and more dangerous ones. These asteroids are smaller than 30 to 20 feet in size.
To implement this idea, a spacecraft needs to be attached to an asteroid. Then, with the help of rocket engines, it will send a small asteroid towards the big one, colliding into it like billiard balls.
If an object with a mass of a couple of thousand tons collides with a dangerous asteroid, it will be enough to divert it from its collision orbit. So it should work. No technical obstacles are visible, although the latest and most cutting-edge achievements of space technology must be put to the test.
You can send an asteroid into what's known as free flotation, which, with the help of a solar sail, this refers to a light mirror which reflects light rays, thereby accelerating the spacecraft. A solar sail uses the pressure of sunlight, photons, and charged particles, just like an ordinary sail uses air pressure.
This technology is often used now and was first tried in 1993 on the Russian spaceship Progress. Then the Japanese and Americans conducted successful tests of the solar sail as a full-fledged engine for light spacecraft. But is a solar sail capable of moving a block weighing tens of thousands of tons from its orbit? Theoretically, it's possible, but sunlight's pressure is very small. And it will take several years of work to divert an object onto a safe trajectory. Therefore, in a few years, we should already know for sure if a certain object will be dangerous for us.
But what if humanity is simply out of time to plan a mission to install an engine on a meteorite? Perhaps we will use a nuclear weapon, but international policies might get in the way.
The deployment of nuclear weapons in space is prohibited by an international treaty that came into force on October 10, 1967. When an asteroid speeds towards Earth, can the leading powers negotiate and mobilize resources to repel the threat? And if each country decides to defend itself by any means, what consequences will this have for the planet?
Scientists are unanimous. A poorly prepared nuclear attack on an asteroid will only aggravate the situation. Instead of a single object, we will have dozens and even hundreds of large pieces. Thus, the area of damage will only increase, and it will be much more difficult to predict where the fragments will land, as opposed to a whole asteroid.
If you crush an asteroid into pieces the size of a brick, and they stay connected and close-fitting, it's quite possible that it will pass through the atmosphere as a single object, and this isn't going to help us. Calculations made suggest this scenario is possible. Therefore, we need to crush it further away from Earth, so these pieces disperse, and each one flies through the atmosphere independently. Such a meteor shower can have many negative consequences, but it will be less dangerous than the fall of a single body.
Unfortunately, now we do not have the technology to deliver a nuclear weapon to outer space. NASA and Roscosmos only recently started to be concerned by possible meteorite threats. Russian nuclear physicists are now doing model calculations to discover which atomic bombs would be most effective against asteroids. Can you blow them up on the surface, or do you need to drill a hole deep into the celestial body?
If you explode a bomb on the surface of an asteroid, its deflection or dispersion consumes about 15% of the released energy. But if you blow it up under the surface, not at a very great depth, like 10 to 20, 30 miles, then 90% of the energy is released and directed towards the asteroid. And this ejection will deflect its movement. Then we need to look at how far this has happened from Earth and whether the impulse is strong enough for it to pass by us or not.
In addition, there are various types of asteroids: rock, metal, and ice, and we must deal with each of them differently.
Because the object can be loose, consist of lumps which are somehow connected there by ice and so on, or it can be monolithic. We need to investigate it to make sure we won't create even more problems for ourselves when, using a chosen method, we begin changing its orbit. In the Makeyev Rocket Design Bureau in Russia, the designs of two aircraft, Kapkan and Kaisia, have been developed. One is to investigate an asteroid, determine its physical and chemical characteristics, specify the orbit, because if the object has only been discovered, its orbit is not well researched to understand its future path. The Kaisia spacecraft is used for this, and then the second spacecraft is used, if it is necessary to change the orbit or to destroy the body.
The second spacecraft, called Kapkan, is supposed to carry a nuclear weapon. The implementation of these proposals would protect the planet from asteroids measuring 2,000 to 2,300 feet. But unfortunately, we have not yet begun constructing these devices.
Theoretically, they are there on paper, in publications, in conference minutes, and presented only in this way.
Apparently, protecting ourselves against asteroids is a very international problem. At any moment, an unwelcome guest from outer space, even from another galaxy, can knock at the door of our planet. On October 19, 2017, NASA astronomers first discovered such an asteroid and named it Oumuamua. It's very long, which makes it look like a cigar. Such forms have never been discovered among comets or asteroids in the solar system. Scientists suggest that Oumuamua came to our galaxy from the star Vega, located in the constellation Lyra.
Interstellar wanderers are the most dangerous because they are the hardest to detect. They can be quite large in size. Here, for example, is the evidence of such serious cosmic collisions. We observe in our solar system. Uranus's axis of rotation is tilted sideways. It takes a monstrous blow to turn the entire planet 90 degrees.
The main danger is that the interstellar wanderers do not have an orbit. They pass through the entire solar system like a bullet. It is likely that scientists will find such an asteroid only a few hours before it collides with Earth. How do we protect our planet in this situation? In Hollywood films, in case of extreme necessity, ballistic missiles are being prepared for launch. But is it possible to shoot down a meteorite?
Максимально тело может двигаться
The maximum speed that a celestial body can fly towards Earth at is 45 miles per second. The speed of a slow-flying object cannot be less than 7 miles per second. The current real air defense tools that we are developing both in Russia and in America have never dealt with such speeds. We can launch rockets at much lower speeds. And of course, interception algorithms are designed for lower speeds.
So even the most advanced missiles require modernization to fight against asteroids, which will take years. And perhaps in the future, the leading world powers should revise the ban on the withdrawal of nuclear weapons from space.
Theoretically, an atomic charge will do for this task. But very specific missiles are needed. And maybe if they orbited Earth instead of being located on the ground, they would be better in terms of response speed and the distance at which they could detonate the asteroid. There's no need to waste fuel on launching the missile from Earth. It requires a lot.
It turns out that we need time for implementation of all projects to combat asteroids. But humanity might not have time on its side.
Back in 2001, a group of American scientists published shocking calculations in the Journal of Spacecraft and Rockets. It turns out that humanity may simply not have enough time to organize an expedition and send it to destroy a large asteroid. Then we will have to find some other methods. We will have to use what the military already have on the ground. Such plots haven't even occurred to Hollywood screenwriters yet.
However, we shouldn't be pessimistic. Earth is very unlikely to collide with any large asteroid in the next 100 to 150 years. And we can survive a collision with a smaller object.
We must remember that if a 300-foot asteroid hit Earth and falls into an ocean or in a boreal forest, we can simply ignore it and refrain from action. If it falls into a densely populated area, we must evacuate. Of course, there will be a crater about 0.6 miles in size, and severe destruction, and fires across a 6-mile radius. Well, it will be like a powerful atomic bomb, only without any radiation. But with the help of the Ministry of Emergency Situations and the Army, we can quickly prevent it and then begin rebuilding the city.
However, even this scenario is very improbable. We're most likely to be aware of the collisions years before it happens. After all, the majority of potentially dangerous asteroids will soon be detected by astronomers.
Regular observation reveals more and more about such asteroids. It can be expected that, without making any extraordinary effort, we will know almost all of them in the next 15, 20, 30 years. Then we'll only have to monitor them to see whether they have changed their orbit or not. We will have to calculate it for the next couple of centuries and monitor again to see if they are getting closer to Earth or not.
Perhaps, over time, mankind will learn how to change the trajectory of asteroid movement easily. The main thing is to make sure that the pursuit of new technologies does not turn into another arms race. After all, nothing will prevent one side from turning the asteroid towards their enemy, to cause a catastrophe on a huge regional scale. Moreover, the aggressor will also remain innocent in the eyes of the world community.
Such a problem exists. Deliberately changing the orbit of an asteroid in order to damage a potential enemy. It is advisable to create special monitoring systems in order to have an independent source of data on the situation in near-Earth space, to study the problems of asteroid-comet hazards and the number of near-Earth asteroids. This is the cosmic threat of the 21st century, which can be much more dangerous than the natural one from a meteorite. Do not forget that mankind's greatest enemies are our own vices, and the probability of a nuclear war is much higher than the probability of a large meteorite falling. But personally, I am sure that in the future, scientists will figure out how to protect our planet from asteroids. My name is Vladimir Surdin, and this is A Guide to the Universe.